Hello. Okay. It doesn't show. Okay, yeah, let's see.
Yeah.
Interesting. Okay, hi everyone. Welcome to the Foam Developer AMA. This is our first AMA, so bear with us. Let's see. We have 8 watchers, 7 watchers.
Dropping.
Okay, it's a good start.
3 likes though.
So let's start by introducing ourselves. My name is Kristoffer. I'm the CTO of Foam. And with me,
I'm Martin. I'm the lead blockchain engineer at Foam.
And today we're going to talk about some questions that we have received over the past couple of weeks about what we're doing and what we want to achieve the coming months. As we released the very private beta of the spatial index, there's also some questions that we want to discuss around that application that some of you might have tried out. Yeah, and we're going to take it from there. Let me see. Okay, there's no questions. So there are some questions coming in. I think we will start by answering some of the pre-recorded questions that we received up until today, and then we will address the incoming ones. So maybe first a quick recap and introduction to what Foam is. So very simply, Foam is really 3 things. On the one hand, it's the cryptospatial coordinate standard proposal that uniquely ties a smart contract on the blockchain to a physical address. You can read more in our blog posts about that. The second component is what we call the spatial index, which is a block explorer that is utilizing the map as the basic view. We like to think about it as a Bloomberg terminal crossed with a Google Maps, where you can track any blockchain activity that inherits or utilizes the cryptospatial coordinate standard. The third component is proof of location, which is our most ambitious track, which is a time synchronization protocol and a cryptographic token that incentivizes people and companies to deploy radio beacons that talk to the Ethereum protocol or blockchain and provides timestamps messages through radio broadcast, which when sort of received by mobile phones or other radio receiving devices, can ultimately create a cryptographic proof of location. So let's start with some of the questions that were sort of directly related to the spatial index.
The first one is, and these don't have names attached to them, so sorry, but is it possible for the owner of a cryptospatial coordinate to move it once it has been placed, or would the funds and any associations with that smart contract have to be transferred to a new one?
Yeah, so in the current cryptospatial coordinate standard, one of the main points is that the mapping or the pairing between the smart contract address and the geohash or the location is immutable. Once it's on the blockchain, it can never be changed. So the direct answer to the question is no, but that doesn't tell the full story. So much like smart contract addresses are immutable on their own, there are sort of other smart contracts that can maintain a list of references to multiple smart contracts and act as a proxy for them. So you can think about a similar example is for Uport and their handling of identity, where identity itself is not given by just a smart contract's address, it's a proxy contract, and then you can update through calling that contract what actual contract address you want to be using for that specific transaction. Another question we've received is, I have an idea for an app that I want to build using the spatial index. What languages should I start learning to make sure that to make it happen?
I can answer that one. So the short answer is that you can learn whatever languages that you want. We put a lot of emphasis on making a pretty sophisticated set of backend services that are able to sort of abstract away a lot of the Ethereum and Web3 peculiarities that come with doing blockchain development. We use sort of traditional data stores and caching services so that the API from an external observer's point of view is very similar to other REST APIs and WebSocket APIs that you probably have used in the past. In terms of posting new content relevant to the spatial index and the proof of location protocol, the standard sort of JavaScript web stack is currently reigning supreme, but we offer a alternative solution to that, which we have developed, namely through PureScript or Haskell stacks. So if you're a PureScript developer, or you know what that is, or if you're a Haskell developer, or you have ambitions to one day become one, you're in a pretty good position because we offer a lot of custom tool sets built in those languages that are sort of directly connected with the work that we do here. But it's basically, the short answer is that it's not important that you need to know those, but it's certainly helpful.
Okay, another question is, will there be API access to place beacons in the future? I can see a possible need to be able to programmatically add beacons with more precision than are possible with the map click. And so I can answer that absolutely. Just sort of similar to the answer previously, we are offering an API for all of the functionality that the spatial index supports. And the spatial index, as you see it now, is basically just our first take at a demo app that utilizes the API. There will be a blog post soon where we outline sort of the principles of the API and how to access it. We haven't made that public yet, but absolutely, that will be possible. And to answer your other question, the precisions that is selectable through clicking is somewhat arbitrary. It was just a choice to make it simple. You can certainly use as high precision as the CSC standard allows using the API.
Along the lines of data access, will there be a way to query all of the beacons and underlying data? There are already ideas that are surfacing that are about finding good places for beacon placement. Maps and data visualization could be used to highlight coverage opportunities. So that's sort of still, I guess, a very relevant question or related question to the previous two. Basically, like we have an API whose specifications are possibly currently reachable, but if they probably need some explanation and justification, which is coming out in a future blog post. However, I would also like to say that because this is a blockchain application, which theoretically anybody who had access to an Ethereum node would be able to view all of the relevant geospatial data that's processed through our smart contracts. We have no problems with helping developers figure out how to, come to us for custom sort of API calls that we're not offering, or perhaps you would like to run your own instance of our data processing unit for your own in-house data needs. We're also open to things like that. We are able to support other projects in a similar way to ours using our sort of data processing unit if you're willing to host it yourself.
Yeah, and so that kind of sidelines into the next question, which is just a question about what networks we support, private blockchain networks, main public, or even test nets and so on. And so our system is kind of agnostic to what kind of Ethereum blockchain you're running, as long as we have access to a node that is fully synced with the network so that we can process the events. We can certainly display all the geospatial events on it. In order for the current version of the spatial index to be interactive, meaning that if you want to put a beacon on there, you certainly need to have write access to that blockchain, which I presume you would have if you're in a private blockchain context. So, but that also related to the previous question is that our data processing pipeline, the one you're currently seeing, is utilizing a number of backends, Redis, Postgres with their PostGIS extension, and Elasticsearch. And so, for example, we are only utilizing a fraction of the capabilities on the PostGIS backend. If you have certain specific queries that you would want to use, we could just target your server, for which you have an API, perhaps.
Six.
Yeah.
No. Oh, 6 is if this was a real world situation after claiming a beacon on the spatial index, would I have to immediately have a beacon out there connected and running? Can I claim areas in some way until I have my beacons ready? Can you describe briefly how that works? Yeah,
that's a good question. And so the idea behind the current demo of the spatial index is that the blue dots represent these Ethereum compatible radio beacons in physical space. So the layers that we added are triangulations and arcs sort of displaying some kind of communication between a movable beacon and these radio beacons in physical space. So on the other hand, they are not yet there. That's our third track, and we are not done with that. So on the one hand, the demo just shows you how that will eventually work. But because the CSC standard is really totally general in that it can be used for any smart contract that needs to reason about space, you could also imagine future versions of the spatial index that display other CSCs that do not aim to represent these radio beacons, but maybe just are some application-specific data in space. And so we would, and this is on our to-do list, be able or have to be able to differentiate these two visually. And so you would still have these blue dots representing these future hardware beacons, but you might have pink dots that represents another smart contract. And certainly our architecture supports extending this kind of arbitrarily far.
7. The spatial index looks great. I was able to see the triangulations, arcs, beacons, bots on the NYC area of the map, but couldn't get much to appear in the area that I placed beacons in Colorado. Is that because I don't have enough coverage with my beacons? How can I add my own bot to move around in my beacon area? Will the beacons react to the bots that pass by in some way? Well, the answer to the first part about why you couldn't see them, if any of you were testing the beta yesterday, there was a small problem when it was initially deployed that was causing some of our services to crash. However, that has been fixed with the work we did yesterday. And now you shouldn't be experiencing this kind of delay if you were experiencing the delay yesterday. The bots are, they are actually just coming from data that we had pulled from Uber riding around in New York City. So the bots are not currently very changeable. We cannot move them to Denver. However, in some ways, like we are, this is something that like could be added in the future or even coming up pretty soon is basically like a way to talk about bots in more locations than New York City, so you might have a more realistic feel for your own cities.
I also mentioned that because we started with New York City, where we have added a lot of CSCs, the triangulation layer uses a fixed distance threshold that's sort of adapted to the density that we have in New York City, which kind of explains why you might not see any in your area unless you put them at the similar distance apart. That's also something that, now that we've released it and we're looking to, we're seeing that users are adding more points, we can eventually remove the points that we added in New York City and possibly make this triangulation threshold user adaptable so that users across the world can have a better experience. This is stuff that we're learning from seeing how users are using the spatial index. I'll ask, okay, second to last question here is, why is it preferred to create a new beacon network rather than attempting to leverage existing devices, phones, etc., to comprise the network? That's a really good question. So generally speaking, we believe that a network of provably time-synchronized radio beacons is necessary in order to provide real proof of location. And so that's why we're working on that. In principle, existing networks could be superimposed on this network that we are creating and deploying, or we're also letting other people deploy together with us. And if these other networks and their devices are Ethereum compatible, meaning that they can send transactions to the network and they choose to use the cryptospatial coordinate standard, they will automatically show up in the spatial index as well. And it's one of the things that we're really excited about and are anticipating. It's this sort of like overlay of multiple different networks. And in principle, as long as you just have one that can provide real proof of location, the other networks will eventually sort of, by proxy of that network, also have a proof, quote unquote, of their location by transitivity. So short answer, to have proof of location, we need to create proof of time-synced mesh networks of radio beacons, but we're certainly anticipating and looking forward to merging that with the existing networks. Okay, the last question, I'll let you answer it, but can you describe the window that appears when you click a beacon? What does FT mean? The beacons will work with Ether and Bitcoin somehow, and that's because Ether and BTC are shown. That's a really good question.
So the really short answer to that is that it's sort of just a mock of what one might want to view in terms of their beacons traffic. And also, FT stands for foam token. It's the token that, in theory, would drive the protocol forward. And in relationship to its Ether price or its Bitcoin price was only displayed just because they are popular known currencies that one might consider the value of a beacon more natively in terms of its Ethereum balance or its Bitcoin balance. This is just to give you a sort of sense of familiarity with what the value of the beacon might be perceived as. Although it's not so absurd to think about this in terms of if they were talking about the holdings of the beacon, it's not so absurd that in some point in the future with these sort of emerging next generation sort of cross-chain compatibilities that are being spoken of to talk about transferring value into these other currencies, it's not a central feature of the app. It's just for display purposes at the moment.
I'd also just add that if you were to click on a beacon, or at least some of the beacons in the New York City area, you will see sort of a token transfer history. This is currently mocked, but which will give you better indication to what this window will show. It will show you a history of sort of the amount of tokens at that location, as if that CSC was an ERC20 contract.
In the future, this window will also display more geocentric data about, or sort of more data that's being produced by the proof of location protocol that this node is partaking in. For example, what sort of zones does it belong in? What is its history in terms of executing the protocol, not just its token balance or its monetary value?
So these were some of the questions we received up until this point. We'll read some of what's come in during this past 20 minutes. No. All right, let's see. Okay, that's all. Someone really likes PostGIS. That's awesome.
The first one, oh God. As a member of the Trusted IoT Alliance, what is your relationship with projects like Stream, IOTA, VChain, or Qtum? Probably the best person to respond to this would be our CEO, Ryan, because he has the most direct relationships with our sort of IoT partners. But Chris, do you?
Yeah, so we just very recently joined the Trusted IoT Alliance. We're definitely partaking in all the discussions there. We don't have any formal relationships with any of these projects. Due to our sort of history as developers, we have a current bias towards Ethereum, and we're comfortable using that. Generally speaking, we believe that ultimately proof of location will be blockchain agnostic. So it's just not something that we're prioritizing right now for the first iteration.
About the beacon, do you have any lists of possible hardware in the market to be used as a beacon? Any references?
Yeah, so again, that's a better question for Ryan. I'll make sure to forward this to him, unless he's actually watching. So our current favorite potential technology, for lack of a better word, is the LoRa chip and the associated devices around that. It's a really feasible standard to use, and there's, perhaps more importantly, already, even in New York City, people running LoRa nodes and have them deployed around the city. So we're looking to partner and develop with both enthusiasts and professional companies. And our current best bet is LoRa, but I know that Ryan has sort of more candidates out there.
This one is from Bay. Do you have any live demo dApp on Foam? That's actually a pretty good question. We don't currently have a demo dApp that utilizes the Foam protocol. We just have the Spatial Index Explorer, but there have been another number of proposals for doing this. I know that people talk about making a demo app for sort of KYC purposes for different reasons. There's things that are similar to Foursquare in nature that people talk about doing here. It's definitely something we're interested in doing, and just haven't really had the time yet. We're hoping that people maybe come to us and who are capable of developing demo dApps that might be interested in doing it outside of Foam, but in collaboration with us, and they would definitely receive our full support. So,
yeah, and so why is the Foam token essential to this project? So basically, the simple answer to that is that in order to have any kind of security guarantees for the staking that you want the beacons to participate in, you need a token. That's how we see it. It's hard to coordinate activity unless there's some kind of staking involved. So that's why we use the Foam token. It doesn't mean that the fees for proof of location are using Foam token. It's simply a means to stake value into the work that needs to be done for these radio beacons. So I thought we could take an opportunity to talk a little bit more about sort of what our vision is, maybe a bit more generally. about Ethereum, the kind of software we're developing, and ideas that we have around that. I'll look into this chat box again in a minute. In the meantime, so let's see. This we can skip. So we received a question. So Martin and I went to ETH Denver a week and a half ago, and I guess we can talk a little bit about that. It was a really great event. I think there were more than 1,000 developers there. Pretty chaotic, but really inspiring to see so many developers. We choose to sort of somewhat ad hoc participate in the 0x specific challenge. Basically out of two reasons. On the one hand, Foam is somewhat intimately tied with decentralized exchanges, or let's say future decentralized exchanges. As Martin was elaborating about this window that comes up when you click a CSC, we're really aiming to have a fully fledged sort of, in fact, more operational block explorer and exchange explorer than you've seen to this point in any other project. So part of that challenge is to develop a fully generic stack that can sort of handle multiple currencies at the same time, track all their indices, make statistics, and show these as graphs. And so although we've developed a really general purpose Haskell and PureScript stack to reason about smart contracts, we thought, okay, we have 36 hours, maybe we put some of these tools to use to investigate what we can do using the 0x protocol. We ended up winning that competition, and I think in part that was because despite like our very short amount of time, we came up with a pretty robust, basically Docker image, which just means that you have like a one-click or button press deploy of a complete database system that basically just tracks every single transaction on the 0x protocol and all of the relays' respective order books, and puts them in the same database. It exposes an API to them so that you can very quickly, make analytics or about arbitrage opportunities, whatever kind of information you're interested in, and ultimately just fire off transactions that you want to sort of utilize that arbitrage. Martin, do you want to talk a little bit to what you see as like maybe even running a future relay?
Yeah, basically like our sort of, or at least mine, and I hope other people who I'm working with here, the philosophy is that for a lot of these decentralized applications, like things that are on top of the 0x protocol, like these relays, or things that would run utilizing the Foam protocol, is that with the exception of sensitive metadata about users, which there shouldn't really exist any for any blockchain-facing transactions, there's really no reason to have a private database that we would offer you access to via our APIs that would be serving in principle the same data that you would get for free if you just had been building up the software to plug into the Ethereum blockchain or what have you in order to figure out what's going on. So the philosophy is that really, if you're developers or you're any sort of software-based company that has special data access needs, and you feel competent enough to run those kinds of queries directly into Elasticsearch or Postgres or Redis or GraphQL, any kind of GraphQL wrapper on top of that, we should probably just give you access to the Docker images that host all of these backend services that collect this data, and you can do it yourself because you know probably what you want better than we do at that point. And it's probably faster for you to write the queries yourself than it is for you to post them in our GitHub issues, and maybe we get to them when we feel like it. So this was an exploration in sort of like thinking about what it might look like to make these general purpose Docker images for the 0x protocol and relay system, basically saying that we just want to fire up a Docker image as fast as possible that has multiple different access patterns, namely through a REST API backed by Postgres and a GraphQL wrapper on top of that, and just let anybody who would like to utilize all this data to do it without the need to go through a sort of centralized governed API service like a traditional software stack would have.
Maybe like decentralized middleware.
Yeah, decentralized middleware is like yeah.
You heard it here first.
Yeah.
Okay, another question is, what are the next steps for the spatial index now that the closed beta has begun? And briefly, I mentioned we want to make the API public. That's definitely a priority with accompanying documentation and a blog post that outlines that. We are actively working with other partners to sort of make custom versions of that. We're already pretty much done with the UPort integration, but specifically we're also working to collaborate with applications that are already sort of have lots of data on the blockchain. Not yet on the blockchain, but in the real world. I would say that another sort of thing which we can start focusing now on are like just examples of ERC20 and CSC contracts, basically append more functionality to whatever these contracts are that are utilizing the CSC standard, and start experimenting with how we can track those either by graphing or, you know, we don't really know what to do there yet. But that's one of the things that as we develop that, it will kind of just come for free now into the spatial index. I'll ask this question and let you answer. What were some of the major roadblocks you met in developing the spatial index?
Probably the most are centered around the sort of Web3 stack, and like it's a sort of a work in progress. I think a lot of it is sort of a work in progress. I think a lot of what is assumed to be, there are certain things which are assumed to be fixed, like for example, the MetaMask Infura combination, and using that as your primary Web3 provider in the browser can have some unintended consequences if you're not paying for their services. There's a lot of things that from a traditional software stack's point of view seem highly ephemeral or unstable about the Web3 stack that made it difficult to develop. And I think that the philosophy here is that it's better for everybody if collectively people working on foam only have to do that one time as a group together, and then nobody else has to go through that again, and that we're going to try as hard as possible to provide most of the things wrapped in traditional software garments, basically. So we're more interested in things like WebSockets as opposed to ephemeral event streaming from some RPC node that you may not control. You're welcome, of course, if you have your own reasons for doing so, to run your own Ethereum node and your own sort of like event streams. But we wanted to provide people who didn't want to get into that level of detail with the option of opting out of it.
So maybe just an addition here that, so if you're a sort of like an already entrenched Web3 developer or a seasoned Ethereum developer, you might see little sort of gain in using some of the tools that we developed because you've probably learned all the same mistakes that we did. On the other hand, if you're, for example, a beginning functional programmer or an experienced one, and you have less experience with Ethereum, I would venture to say that if you look into our libraries and the sample applications that we have released, you can sort of use our libraries and you what's the word, like bootstrap, or no, like you get a kickstart, so to speak, and you don't have to deal with a lot of the issues that are intrinsically in the Web3 stack, but which we've worked around in a type safe kind of manner. So I would encourage any a developer that maybe has less Ethereum experience but have some interest in functional programming to experiment with our tools. And you might just find that you can actually write blockchain applications. They don't have to have anything to do with foam or spatial data, and you might just find that you're able to do that much more rapidly than if you had not used our tools, or if you had to reinvent them from scratch. And so on that, I'll just ask the last question. 1 second, there's one more here. That's like just, so I was saying how our libraries kind of like embed this knowledge. And so a question here is, what was the biggest challenge in writing the PureScript Web3 library, which basically Martin is the primary author of?
Yeah, so, quick context is that PureScript is a strongly typed functional programming language that currently targets the browser, or targets JavaScript and therefore the browser. So it's sort of a, many people who write Haskell, for example, are prone to like it for writing front-end applications because it has a very similar feel to that. It's not necessary that you know Haskell. It's probably actually better if you don't, in order to start doing these things, because the language is a lot sort of more modern and clean than Haskell is in a lot of ways, but provides you with sort of the same ability to reason about what the application is doing before you try to turn it on. And I think that the hardest thing about maybe writing that probably was, well, PureScript doesn't have a metaprogramming language. Haskell has a language, sort of metaprogramming capabilities using something called template Haskell. And it's difficult to have something, to be able to do something like take an ABI or a JSON description of what a smart contract is supposed to do, and then provide the PureScript code for it that must be generated statically because of how the language works. So in JavaScript, you can just give this contract object, you can give it an ABI as a JSON type, and it will dynamically create all of the accessors and event monitors for you. Whether or not they work is up to you to find out. But what we can do in the PureScript library is to statically generate these contract files from the ABIs as modules. And then there's two main advantages to doing this. One is that it's cheap to build them. And if you have made application code that sort of imports all of your contracts as a library, then if you're still toying with contracts and they're not done and you want to rebuild them and try to plug them into your project, if you've changed the contracts in any way that your application doesn't like, you'll get a very informative error message when you try to build the project. So that's really good for, especially during experimenting phase, but also even beyond that, it's just good to know that as much as possible, you're using the FFI offered by your smart contracts in exactly the way that it's supposed to be intended. And so I would say that the hardest part of it was really was making up for the fact that there is no metaprogramming language and being able to generate these contract files consistently and have them be short and readable, human readable and understandable, and having those requirements made it so that it was pretty difficult to write the library like that.
I'll add a link in the comments later, but I would encourage anyone to download our KittyMonitor app, which is basically the sort of PureScript Web3 sample app. That the way it works is that you download the ABI, or we provide it for you, from Etherscan to the CryptoKitty smart contract, and the application, or at compilation stage, it basically creates the corresponding modules for accessing the events and the functions on the CryptoKitties, and it somewhat automatically generates an app that's able to track all of the events as they're unfolding on the blockchain. Obviously, actually, the only reason we choose CryptoKitties is because it's one of the few Ethereum applications that generate sufficient amount of events so that you can actually meaningfully debug the application.
Yes.
But people are still treating CryptoKitties, so it's a good start if you want to get sort of like a 10-minute overview of how PureScript Web3 works. All right, like this one. So we're here. Okay, ACDC asks why use Haskell Stack. I think we maybe some way answer that. I can just fill in. So whereas on the front end we have this PureScript stack that lets us sort of in a type-safe manner write UIs and process events on the blockchain as mediated through MetaMask or whatever Web3 provider that you have. On the back end, where we are feeding events from smart contracts into different databases, we need a similar kind of backend service. And for various reasons, it doesn't make sense to use PureScript there. It does. Haskell has a wonderful sort of like modularity in that, like, you can write the specific code that lets you do the thing that you care about, and then just by virtue of its modularity, you can connect to all kinds of databases pretty much for free. So one of the neat things we do there is that, for example, from the ABI, it generates the Postgres schemas, for example, in a fully automatic way, and so we can handle migrations and so forth. Okay, there's a question about tokens here again. So the token is not live, so I will answer that maybe in the future. Will Carter asks, okay, so global partner program with Foam, it's not clear what that question means. In any case, it's probably better directed to our CEO. Will Carter asks, can you post a link to your East Denver Hackathon project? Certainly, I'll post that right after this is done. Don asks, can Foam be used as a trustless record of shipment or transportation? So yes, that's one of the applications that we're envisioning. Supply chain on the blockchain is something that a lot of people are talking about. You want to track a lot of different aspects of your assets, one of them being location. So quite simply, what we're envisioning is a mesh network of these beacons that can provide proof of location. And you basically have a package, or a package proxied by a person holding it or carrying it, whatever, that basically checks in time with these radio beacons, and then providing metadata about this package having been where it was. And because it's on the blockchain, it could then trigger all kinds of events, such as payments, opening gates here and there, and whatnot. I think one additional sort of interesting venue here is that for a lot of supply chain applications, GPS is not sufficient. Obvious reasons are, for example, spoofability and denial of service, which GPS suffers from. But more interestingly, a lot of the supply chain applications actually happen indoor and at a precision that GPS is not able to provide. So whereas Foam is really in some ways scale invariant, if you like, and so if you have a warehouse, you can deploy Foam beacons and get a very high precision proof of location that's completely independent of GPS, and that's certainly like sort of like a new area that we're envisioning. Is it possible to deploy a beacon without exposing its exact location? That's a good question. Well, so I would have to ask currently, no. We are working under the assumptions that the beacons act as kind of, we call them zone anchors, meaning that they have a relatively, they have an absolute position. And then sort of proof of locations and movable beacons will always have a position relative to them. It's certainly interesting to think about possible ways to do this without actually revealing the exact location. I can think about some venues there. It's certainly not something we're prioritizing right now, but I can certainly see that as being a research area that might be, started after we've gone through phase 1 of actually deploying these. Maybe you can help us. All right.
Seems like that's it.
Mm-hmm. Anyone has any other questions? So I guess we end it there.
Yeah. Okay.
Thanks a lot for listening. This was our first AMA. I hope to have further ones. If you have questions, just go to our Telegram and keep asking questions there. Or if you're a developer, start using our tools, our APIs, and get in contact. Bye.
Bye.
How do I hang up?
It's the